What did you guys get for 29? Which of those graphs matches up with 29? Brady? You got D? Nick, what'd you get? A. Nick, how'd you get it? Very good. Are these in standard form? Absolutely. So the main thing, guys, when they're in standard form, the one thing that we should always do is find the intercepts, okay? Now, how do we find the x-intercept, Nick?
Using the y, so that is 5x plus 3 times 0 equals 30.
Perfect. Okay, so this goes away, and we've got 5x equals 30.
And 30 divided by 5 equals 6.
Brady, if I see them again, I'm going to take them. Okay, your y-intercept is when x equals 0, and you should have gotten 5 times 0 plus 3y equals 30. The 5 times 0 becomes 0, so we just have 3y equals 30, and then we divide both sides by 3. Once we do that, we get y equals 10. Now, we just found where our graph crosses the x-axis and where our graph crosses the y-axis, okay? There's only one graph that crosses the x-axis at 6 and the y-axis at 10, and that graph is A. Notice this point is 0, 10, and this point is 6, 0. Where does B cross the y-axis? Aya?
Wait, what'd you say?
Where does B cross the y-axis?
1 to 10.
Yep, 0, 10. Where does B cross the x-axis, Gabby?
-6.
-6, 0. Okay, so that's why B is not our answer. It does cross at 10, right, on the y-axis, but the x-axis is at -6. Gio, where does C cross the y-axis? -10. So this point is 0, -10. Oops. And where does it cross the x-axis? Aiden?
-6.
Good. -6, 0. Yeah. We've got a line going. Okay. D. Valerie, where does D cross the y-axis?
Crosses the y-axis
At -10. And the x-axis? Okay. We're going to use this information to help us figure out which equation matches with the graph. Okay. So 29 was A. 30. Well, let's find the axes. We've got 5x plus 3y equals -30. How do we find the x-intercept? Aya?
Solve for y.
Nope. Valerie? Very good. You make y equal to 0. So we're actually solving for x, okay? So if we make y 0, we get 5x equals -30. JJ, how do we solve this?
Divided by 5.
Excellent. So we get x equals?
-6.
Perfect, okay? So we're looking for the graphs where our x-intercept is -6. Do you guys see that? Okay. Which graphs have an x-intercept of -6? Which two graphs have an x-intercept of -6? Nina? B and C. Very good. Now, we don't know which one it is because we have to find out the y-intercept, okay? But as long as we're on the same page that it can only be B or C, that's good, okay? Now, let's go ahead and find the y-intercept. Victor, how do I find the y-intercept?
Which one?
Any of them.
The y-intercept.
What do I do in order to find the y-intercept?
For that, you would make x 0.
There we go. Make x 0. Okay, that's the same no matter what problem. Okay, so we make x 0. What's my new equation, Victor? We're working on 30.
So it would be 5 and then in parentheses 0
Uh-huh.
plus 3y equals -30.
Yeah, you're right. I wrote that wrong. Negative 30. Okay, so our new equation is 3y equals negative 30. Jonathan, how do I solve this?
Divide by 3, getting negative 10.
Excellent. Y equals negative 10. Okay, so which of these graphs between B and C crosses the y-axis at negative 10? So we narrowed it down to B and C based on the x-intercept, but which one of the two crosses the y-axis at negative 10? Gia? Booyah, it is C. Okay, so 30's answer should have been C. Okay, if we do the exact same method for 31 and 32, what do you think 31's answer is? Did anyone get 31? Pedro, what'd you get?
I got D.
You got D?
Yeah.
And 32? B? Very good. Okay. Any questions on the warm-up? Today is a super important lesson. Today we are learning about slope-intercept form. So you remember when I showed you all those Marvel characters the other day? Right? This one is Thanos. This is the bad guy, okay? He's probably the most powerful, right? He basically destroyed the entire planet. Well, half the planet, okay? I don't know if you guys watched Endgame or not. Or, no, it wasn't Endgame. What was it?
It was
Infinity War, okay? He snapped his fingers and everyone went away, right? So now, look, slope-intercept form is the bad guy. It is the biggest of the three forms that we're going to learn in here. Standard was one of them, but standard's like Captain America. Thanos is slope-intercept form because it's the big one, all right? Now, when we do our problems, okay, listen carefully. I want our graphs to look like Jimmy Neutron's hair, okay? Or someone said he looks like Panic at the Disco, like a young Panic at the Disco. I don't know. I don't even know who that is. Don't make your graph look like this kid's haircut, okay? It should be a straight line, okay? We're dealing with linear equations. Our graphs should be straight lines, okay? All right. So now we are still talking about linear functions, right? Now, functions, why are they important? When you guys get out of here, when you guys graduate from McCarthy, no matter what you do, you're gonna still see graphs, okay? My job is that you can be given an equation, right? And you can know something about its graph, okay? Now, the form that we're talking about today is called slope-intercept form. So guess what information we're gonna get from that form? We're gonna get the slope and we're gonna get the y-intercept, okay? All right, rise over run. And first thing we're gonna talk about is the slope, okay? On your page, you should have some blanks on this slide. Please fill those in at this time. The slope is the rate of change between any 2 points on a line. It is the measure of the steepness of the line, okay? So the first thing we're gonna talk about is what is steepness, okay? And how I teach steepness is once you're done copying down those words, I want you to copy down the 2 lines that I'm going to draw right here. Draw a little stick figure of yourself right next to those lines. Okay, now, looking at the first one, right? This one right here. If that line was your hiking trail, would this be an easy hiking trail or a hard hiking trail?
Hard.
Nick?
Hard.
Why?
Because it's very steep.
It's super steep. Do you guys see that? So the more steep you are, this one's super steep, the slope is going to be bigger. Slope is big, okay? So if you are a steep graph, your slope is very large, okay? Now, if the second line was your hiking trail, Gabby, do you think this would be an easy or a hard hiking trail? Pretty easy, right? But why? It's not as steep. We would call this flatter, right? So if your slope is flat, guess what? It's smaller. Your slope is smaller. Okay? Now, specifically, slope is the rise in the vertical direction divided by the change in the horizontal direction, okay? So put 2 points on this line, and I want you to draw a vertical component that takes you all the way up to the other point, and a horizontal component that takes you all the way to the second point, okay? Do you see how the vertical component is pretty large compared to the horizontal one, right? They're almost, like, I would say the vertical one is bigger than the horizontal, right? This line right here is bigger than this one. Do you guys agree with that? Now do the same thing, but for the flatter graph. So take a point here and a point here, and if you drew your graph correctly, your vertical portion should be very small and your horizontal portion should be very large. Now, what slope says is it says take the vertical component and divide it by the horizontal one, okay? So if we look at these, which slope should be bigger and why? Jonathan, what do you think?
The steep one.
Why?
The first one is taller.
The vertical component is much larger. Do you guys see that? Now, for slope, it's the change in y divided by the change in x, okay? Or the rise over the run. I need you guys all to put a nice little box around this. This is going to be your guide for slope for the rest of the year, okay? Slope is identified as a lot of the times as the variable m. Do you remember in y equals mx plus b, right? M is our slope. It's the rise over the run. It's the change in y over the change in x. And specifically, it's the y coordinates subtracted from each other divided by the x coordinates subtracted from each other. Now, we're going to apply this like a bunch, okay? So don't worry about it if it's not clicking right now. It will click in a moment. Brady, what's up? After Aiden, yeah. Okay. We're going to draw 2 more lines. Look what happens if our, ooh, that's a highlighter. If our line was completely horizontal. Okay? If our line is completely horizontal, draw 2 points. Let's try to figure out the slope of this line. Now, what is the vertical component of a horizontal line? Gabby? There isn't one, so we put 0. So the rise of this horizontal line is 0 over, now, the horizontal component, there's a horizontal component there, right? We did change from one point to the next. 0 over some number. What is 0 divided by anything? Just 0. So the slope for any horizontal line is 0. Your slope is 0 for a horizontal line. And now we get to the fun one. Let's think about what happens. Over here on the left, draw a vertical line and put vertical underneath. we're going to try to come up with the slope of a vertical line. In this case, your slope is a fraction, right? It's the vertical change divided by the horizontal change. So the vertical change here is a number. Do you guys see that? We did move up from one point to the next. Do you guys agree? So it's going to be a number over what?
0.
Y.
Because it's on the y-axis.
There's no change in the horizontal. Do you see how we didn't require a horizontal component to get to the next dot? So it's a number over 0. What is any number divided by 0? Gabby?
0.
It's not 0. Brady?
5.
We don't know. Correct. It is called undefined, right? So the vertical line has an undefined slope. Now let's think about that. If you were to take 0 and divide it by 7, right? What is 0 divided by 7? How many times can 7 go into 0? Nick? No? How many times can 7 go into 0? Gabby? 0, okay. Now, if we were to ask you how many times can 0 go into 7, does 0 have any value? So if you're taking something with no value and you need to add it up to equal 7, will that ever happen? No, because it doesn't matter how many zeros you have, you're never going to get to 7. Do you guys see that? So this is what mathematicians call undefined, okay? Because you cannot divide a number by 0. There's no mathematical explanation for it. Yeah, Jonathan?
I use the restaurant or like
Brady? Okay. Now, if you're confused at this point, I'm okay, okay? But we're going to do 4 examples on the next slide. After that, if you're still confused, we need to talk, okay? All right. Anyone need more time on this? Here we go. I don't know. On this next slide, I need you to take out a highlighter, okay? Pick any 4 colors. I'm going to pick green for the first one, blue for the second one, red for the third one, and yellow for the last one. And highlight each of those equations. We're going to put all 4 of those on the same graph, and we're going to see what they look like. Now switch back over to your pens, and let's go ahead and take y equals 2x, and let's plug in values of x for it. Okay? We're going to plug in the same 3 values the entire time, okay? So we're going to plug in -1, 0, and 1. And then the other side will be our y values. So if we plugged in -1, 0, and 1, let's start with -1. What would our y value be if we plugged in -1 for x? What would our y value be if we plugged in -1 for x? Brianna?
-2.
Excellent. It's -2. How'd you get that?
2 times -1.
Very good. Y is just 2 times, instead of x, we wrote -1, which gave us -2. What if we plugged in 0 for x? What would our y value be? Gio? 0. Excellent. And if we plugged in 1, Gabby? 2. So what we just did was we plugged in values for x and we got values for y. These become coordinates, okay? So from here, draw 3 coordinates. The first one is -1, comma, -2. The second one is
0,
0, comma, 0. And what's the last one, Aurora? 1, comma, 2. Perfect. Okay, so we got 3 points. Let's graph them, okay? So go ahead and put on your graph -1, -2, which would be down here, 0, 0, and 1, 2. And then to the best of your abilities, you guys are in Notability. You guys should be able to draw a nice straight line through those points. I am not in Notability, so I can't do it as nicely as you can, okay? Does everyone know how to draw a straight line?
Yeah.
You just hold your pen down and it creates a straight line. Okay? All right, now let's find the slope of this green line. Before we actually find the slope, let's describe it. Would you say that the green line is steep or flat? Nick? I'd say it's steep, okay? So let's put steep down here. And steep means that it's going to be a large slope or a small slope. Jonathan?
Large.
Large, okay? So we know our answer should be large, okay? Relative to what slope is, right? Normal slope is a slope of 1, okay? So anything bigger than 1 we'll consider large. Anything smaller than 1 we'll consider small, okay? All right, so let's take a look. Pick any point, and from there, find the vertical component and the horizontal component that got you to the next point, okay? I'm going to start here, and I'm going to move how many units up to get to the next point? Liz? 2. So put a +2. Anytime you're moving up or to the right, it's a positive. Anytime you're moving down or to the left, it's a negative, okay? Where am I going to go after that to get to the next point on my line? Brianna? To the right. Very good. How many units?
1.
Just 1. So put +1. Do you see how we ended up at another point on our graph? What we just did was we found the slope, okay? Now remember, slope is, write this down, rise over run. Okay? So now look carefully at our graph. What was the rise component of this movement? Val? 2. And what was the run component, Valerie? 1. So our slope is 2 over 1, which we can simplify to what? Just 2. So we were absolutely right. This is a steep slope. You may not think that 2 is a very large number, right, in the grand scheme of things. But when we're talking about slope, it is a pretty large slope, okay? If 1 is normal, 2 is bigger, okay? Yeah.
If you're going like down the slope, if you ever go down, would it be a negative then?
Let's take a look. So Ayabra brings up a very good question. Let's say we're going down. You can move from any 2 points from any point to another point on your line, and you're going to get the same exact slope. So let's start here, and let's move to the next point. What movement did I just make by this arrow? No, that was a vertical one.
Rise over run.
Hold on. Just look at the arrow that I drew. What movement did I make to go that way? Gabby? Down how many units? 2. When we're talking about down, is that a positive or a negative? Negative. So we went down 2, so put a -2. And then where would we go to get to the next point? To the left, right? Very good. So we went to the left 1. Okay? So our movement, right, was -2, -1. Do you guys agree?
Mm-hmm.
So we're going to put our rise over our run. What was our rise? -2. What was our run? Oops, -1, right? What's -2 divided by -1? Gio? 2. Do we see how we got the same slope? Yeah, Amina?
I understand when you did the rise and the run, I'm just getting confused of the units, getting the numbers.
Okay, so anytime you draw an arrow, right? Think about, okay, which direction did I move? I went down, right? Down and or to the left are going to be negative values, okay? Anything going up or to the right is going to be positive values, okay? Does that answer your question?
Yeah.
Okay, cool. All right, guys, I'm going to erase this. Feel free to leave it, but we're going to get a lot more graphs on here, so I don't want too much of it, like, being occupied. Aya, what's up?
So 1 rise over run is either like it's like up and down and then let me say that again. Rise is like up and down and run is like left to right.
Very good.
Okay.
Think about it like an airplane. An airplane always rises, right? Or falls. And which way do you run? You run horizontally, right? You don't run straight up and down, up in the air. That would be jumping, okay? All right.
No one would survive.
No one would survive. Okay, what's the next one? Blue? Oh, yeah, blue. So let's make our chart of x values and y equals x, okay? X is going to be -1, 0, and 1. -1, 0, and 1. What do I get when I plug in x equals -1? What's my y value? Nick? -1. What's my y value when I plug in x equals 0? Gabby? 0. And what's my y value when I plug in x is 1? Brady? 1. So my 3 points are -1, -1, 0, 0, and 1, 1. Gabby, you have a question?
And like whenever we do this for like the x we always put 3 numbers, right?
You guys would always put 5. Okay? I'm doing 3 because there's a lot of examples here. But anytime you're asked to graph and it says use points, always use 5 points. Okay? Yeah, Amina?
Those numbers that you put, so we can use
You can use whatever you want. You could have used
like 3,
-37, +45, and 0.
like whatever number.
Whatever you want. Yep. You could use 1, 2, 3. You could use 4, 5, 6.
What's the simplest way to use it?
I would use -1, 0, and 1 at all times.
Oh.
Okay? All right. So, -1, -1. Let's graph that. That's right here. 0, 0, and 1, 1. Put all 3 of them on your graph and then draw a nice line through all of them. Make sure your graph is looking like the first haircut, not the second haircut. Why isn't it right? Oh, there we go. Now let's find the slope. Let's start in the middle this time and go to the dot on the right. What were my movements to go from point 1 to point 2? Gabby? Very good. Up 1, so that's going to be +1, and then to the right 1 is plus or minus 1? +1. Remember, anything that you're moving up or to the right would be plus. Anything you're moving left or down would be minus. Victor?
What is the little one for again?
Oh, this is just showing that we're starting here and we're moving to this one.
Oh,
Okay, it's that yeah, that's not like you didn't need to have that in there. Good question. Any other questions on the slope? So what's my rise for this problem, guys? Geo? 1. And what's my run? What? 1. So my rise over run, which is my slope, is 1 over 1. Does that simplify? Gabby? Just 1.
Go back to the graph.
Mhm.
And like we always do the graphs with like the arrows at the end, right?
Yes. Mhm. How many people have seen slope before? Okay. How many people have not? Okay. All right. Let's take a look at the red graph. How many people don't like slope? Okay, good. We're going to change that. So let's put x, let's put y equals -x. Remember, I'm going to use the same x values the whole time. Do you need to use these x values? No, you could have used whatever you wanted, okay? Let's use -1, 0, and 1. If x is -1 and y is -x, what will y be when x is -1? Gabby? +1. What about if x was 0? What would y be?
Wouldn't it, 0?
Yeah, it's just 0. And what about if x was 1? Gabby? -1. Perfect. So my 3 points, my 3 points are -1, 1, 0, 0, and 1, -1. Oops. Let's plot these. -1, 1 is going to be right here. 0, 0 is going to be right here. And 1, -1 is going to be right here. Let's draw this line. Boom, boom, boom. And then let's figure out the slope.
It's basically the flipped around, right?
Ah. So it's the same as the blue one, except it's facing the complete opposite direction. Do you guys see that? So let's look what happens when we find this slope, okay? Let's start from the middle point, the point at the origin, okay? And let's move to this point on the right, okay? What did I need to do? What movements did I need to do in order to get from the middle to that point on the right? JJ?
Down and to the right.
Down 1, good, and to the right. If we move down 1, what number should I put next to that vertical line? -1. And then if we move to the right, +1. Do you guys see that? Okay, so we moved down 1 and then to the right 1. So our slope, again, is rise over run. So it's going to be -1 over +1. What's -1 divided by +1? Nick? -1. Do you see how the slope of the blue line and the red line are the same? The only difference is that one's negative and one's positive. They're the same steepness, but the red line is going down as we move to the right, okay? That defines a negative slope. Valerie?
Do we have to simplify it all the time?
Yes, always simplify it. Jonathan?
Table that can find that.
Yeah, you can move one of the desks in the back backwards. Okay, guys, we're almost there. Last one. Bear with me, okay? The yellow one. Let's do the yellow one, okay? Here we go. So, in the yellow graph, we've got y equals -2x. Let's plug in those same x values. They were -1, 0, and 1. Brooke, help me out. What do I get when I plug in x equals -1?
2,
0?
0,
And 1?
-2.
Ayo. So we've got 3 points. -1, 2. We've got 0, 0. 1, -2. JJ, wake up. Okay? So, from here, let's plot these points. -1, 2 is going to be all the way up here. Oops. 0, 0 will be right here. And 1, 2 will be, 1, -2 will be down here. Draw a line through those 3 points. Yeah.
Could you zoom in?
Which one?
These.
And Victor?
So it was basically the green one going down.
Very good. It's the same steepness as the green one going down. So, what was the slope of the green one? What do you think the slope of the yellow one's going to be?
-2.
Very good. Okay, let's figure it out. So the slope of this yellow one, right? Let's start at this point up here in the top left, right? How did we get to the point in the middle? What was our vertical component to get to the point at the origin? Brady? -2. Very good. We went down 2. Do you guys see that? And then where did we go after that?
You went to the right one.
Excellent. To the right one, which is +1. So our slope is going to be rise over run of the yellow one, which is -2 over +1, which simplifies to? Brooke, help me out.
-2.
Excellente. Yeah, Aiden?
iPad's at 1%, but I don't know how they're charging.
I can borrow mine.
Good looks. Thanks, Mina. Okay. Are we feeling a little bit better about slope now?
Yes.
Okay.
There's like too many things.
So I just went over slope like really, really slowly, okay? If you are still having trouble with slope, please see me during my office hours, okay? Next week, I'll have my office hours on Tuesday after school, okay? Make sure you come. All right, so we're done with slope. The green graph and the blue graph were positive slopes. Red and the yellow were negative. Just happened. Oh, no, you got to get it from a friend, okay? Let's describe the slope of each of these lines and then let's find the slope. Take a look at A. So remember, and the red. Do we think this line is going to have a positive or a negative slope? Victor, what do you think?
Positive.
Positive, very good. Why?
Because the horizontal line is going to the right and the vertical line is going up.
Very good, okay? You can also think about it as we move from left to right. Is our graph going up or down? Up. So it's positive, okay? As you move from left to right, is your graph going up or is it going down? So we know it's positive. And is it steep or is it flat?
Steep. Flat.
I would say it's kind of flat, right? Steep would be like something like this, right? That's pretty steep. I would consider this more flat than anything, okay? So we're going to say it's flatter. Okay? It wouldn't be the hardest thing to hike, okay? All right. Now, our slope is our vertical component or our rise over our run. What's the rise here? Nick?
3. Negative.
Aya?
4
4
over 6
over 6. Now, if you put this as your slope, you would get points off. Why? Amina? You can simplify it. What does this simplify to? Gabby? 2 over 3. Why? Very good. We can divide both the numerator and the denominator by 2. Remember, whenever they're both even, you can definitely simplify it. Okay? All right, so now watch. Let's take that new slope of 2 over 3 and let's apply it to our graph. So go from -3, -2, go up 2 units, and then go to the right 3 units. Did we still end up on our graph?
Yes.
We did. Do it again. Go from that point, go up 2, and then go to the right 3. Did we stay on our graph? Yeah. Interesting, right? You good? No.
No, I'm fine with this. This is easy.
Okay. What about B? Okay, so first let's describe the slope. Is it going to be positive or negative just by eyeballing it? JJ?
Negative,
Very good. Why?
because it's going this way.
Yep, as you move to the right, it's going down, okay? So it's going to be a negative slope. And would you guys describe this as a steep line or a flat line? It's steep, okay? So our number should be bigger than 1. Well, I mean, it's going to be negative, so it should be like less than negative 1, okay? All right, so it's going to be steep and it's going to be large, okay? Let's find out what the slope is. The slope, there we go. Slope is rise over run. What's our rise here? -3. And what's our run? 2. Remember, rise is your vertical component. Run is your horizontal component. So our slope is -3/2. Okay. Is -3/2 the same as 3/2?
Yes. Oh, wait, no, it's not.
It's
Yeah.
the same.
They are the same. Why are these two the same? Brady? Because what?
Because when you divide them, you're gonna get the same answer.
Why?
Because division with a negative number is if only one number is negative, if you're negative.
Very good. If you have a negative divided by a positive, right? And you do that same number but positive divided by that other number negative, you've got the same answer. These two are the same. Is this the same?
Yes.
Yes. But is this the same? Why is this one not the same? Liz?
Since they're two negatives, when you divide them, they turn to positive.
Very good. If you have two negative numbers in the numerator and the denominator, when you divide those, you eventually get a positive, okay? Now watch. Let's apply this. So if our slope was 3/2, right? Instead of -3/2, let's go from here. Let's start here. Let's go 3 units up plus 3. And if our numerator's 3, oh my gosh, our denominator has to be -2. So we move to the left 2. Are we still on our graph? Yes.
Oh, wait, yes.
Yeah. So you can move either direction, okay? Make sure you understand that -3/2 is the same as 3/2, which is the same as -3 divided by 2. This is where we're going to stop, and we've got, oh boy, denominator number 1. Let's start at the point all the way over here. What do I need to rise in order to get to the next point? JJ?
You have to, wait, what do you mean, like rise?
So remember, rise could be up or down. Do we need to move down or do we need to move up in order to get to the next point?
Down,
Down. And how many units down?
2,
2. So draw an arrow going down and put -2. Excellent, JJ. And what's my next move, Victor?
to move across, which would be 6.
So across is great, but it's not as descriptive as I want it.
Vertical.
Nope.
I don't know.
Across is right, but am I moving right or left?
Oh, right.
Right, okay. Now, when we talk about right, are we talking about positive or negative? Gabby? Positive. How many units did I go? So, my slope is what, Brady?
It's -2/5.
Very good. Hi. Bye. Okay, number 2. How many people got -2 over 5, by the way?
Can you please send Isabella Powers to Student Services?
Yes.
Hello?
Yes. Hello?
Yes. Can you send Isabella Powers down?
Got it. Okay. All right. -3, 1, -1, 2, 3, 3. Let's start. I love to start on the left and just move to the right. Let's start over here. What's my move? Brady? Up 4. 1, 2, 3, 4. Plus 4. And the next one? Grace? Plus 6. So, again, we've got slope, which is rise over run, which is 4 over 6. Why would we get some points off, Carson?
Well, I have like a different question. I wasn't here on Friday, so my
Okay.
friend sent me the notes, but she did it.
Excellent. We had to simplify it. And they're both divisible by 2, so our slope is 2 over 3. Now, if we wanted to check that, right, we could go up 2 units from the red one, and then we could go to the right 3 units. Are we still on our line? Yep. That's a great way to check, okay? So 2 over 3 is also correct. Seth, what's up?
So you always want to go up first and see how much you go over.
I personally like to go up first. If you want to go to the right first, that's fine. I like to go up first because my numerator is my rise, right? So I always want to do numerator over denominator. But if you go to the right, like if you went this way and then up, you would get the same thing. But just remember, your rise is what goes on top, okay? All right, for number 3, be careful here. This one was different because our intervals were by 2. Did anyone not miss that? I missed it, honestly, the first time I did this problem, okay? They're intervals of 2. So it goes 2, 4, 6, 8. 2, 4, 6, 8, -2, -4, okay? So when we're talking about this point, going up to the next point, how many spaces did I move? How many units did I go up? Aya?
6.
Close. Brady? 7. Plus 7, okay? Now look, this one is a half, right? So it counts as 1. This is 2, 2, and 2. So all together, they make 7 units. Some people got 3.5, right? Just multiply that by 2. Jonathan?
You know how you said on the last question you can go from the other side too, but you gotta use the rise first?
Mm-hmm.
You know? What if you tried on that question, because it's a bit different for...
Yeah. So let's start here. We would move down. Do you agree? 2, 4, 6, to a half, 7. So -7. Now, on mine, I would go to the right. 1.5 units here is 3 units with this graph. Do you guys see that? Because it's intervals of 2. So this would be plus 3. The other one would be -3. So you see how we're going to get the same thing? It's going to be +3. Our slope is going to be positive, oopsie daisies, +3, +3 over 7. Just kidding. What did I mess up on? Someone catch it. Nick,
3 is supposed to be the denominator, the 7 is supposed to be the numerator.
why?
Because the 7 was the rise and the 3 was the run.
Very good. 7 is my rise, 3 is my run. So it needs to be 7 over 3. Yep. Yep. How many people got all 3 of those right? Booyah. What's up?
Wouldn't it be easier to do y2 minus y1 over x2 minus x1?
Yeah, but we're not there yet. I want you to see both ways, but you're right. You're right.
Can you go back?
Say that what slope would be if they used 2 different points. For example, if we went from here on this graph to here. Gia? Nope. Rihanna?
Would it be inequality?
Nope. Gia?
0?
Nope. Gabby? What? Nope. Pedro? Nope. Victor? It would be a fraction, yeah. The point I'm trying to get at, guys, is the slope of a line is going to be the same no matter what points you pick. So if we go up a certain amount and over a certain amount, our slope is still going to be negative 2 over 5. No matter what 2 points you pick on any line, it's going to be the same for that same line, okay? Points. Think about this for 30 seconds on your own. What would the slope be? Take those last 3 examples. If you used 2 different points, if you didn't use those same 2 points. And I want you to write down your answer. What would the slope be if you used 2 different points? So underneath this problem, I want you to write, what would the slope be if you used 2 different points? Exactly the same. Okay? Exactly the same. For any given line, right, the slope will be the same for that line no matter the 2 points that you pick. Now, this is super important because of the examples that we're going to do next. We said, regardless of what the slope is, if we pick any 2 points, that slope's going to be the same no matter what. Right? Check it out. When we're given a table, right, I told you guys, it doesn't matter which 2 points we pick, right? Because on the last slide, we can pick whatever 2 points we want from any of these tables, and we can find the slope from them, okay? Now watch what we have to do. Let's say for A, we pick the first one, 4, 20, and let's pick the third one, okay? Look closely at what I have to do. You're going to make one of your points x1 and y1, and the other point is going to be x2 and y2. So, for A, let's make 420 x1 and y1, and let's make 108 x2 and y2. This is what Pedro was talking about earlier, okay? So, our equation for slope, do you remember, is rise over run, but we can also write it in terms of the coordinates, okay? It's the difference in y coordinates, y2 minus y1 over x2 minus x1. JJ?
What would this be called? The charts.
So this would be like, it's still asking us to find the slope, but it's from a table now.
Okay.
Do you remember how before we had graphs for each one?
Yeah.
That's where we use rise over run, right? This is when we have a table. So we can't just look at this and be like, oh, I know what the rise is, I know what the run is. This is where we have to assign points, okay? All right, so we've assigned a value to each of these variables. Y2 is going to be 8. So we're going to write 8 minus y1, which is 20. Okay? I'm just plugging in the values as I see them in the equation. x2, which is 10, minus x1, which is 4. Now I've got 8 minus 20, which should give me what? Nick?
Negative 12 over 6.
Negative 12 over, good, positive 6. Gio?
Do we have to add the parentheses?
I would prefer it. We always add parentheses when we're plugging in for variables, right?
Yes.
If you forgot it, you wouldn't lose points, but it is a very good practice, and you'll see why in the next problem, okay? So we got negative 12 over 6. Is that our final answer, Jonathan?
You gotta simplify it to negative.
It simplifies?
Yeah. And you could divide it, meaning it's negative 2.
Very good. Negative 2. So my slope is negative 2. Now, just humor me. Let's find the slope of 2 other points. Let's pick 7 and 14 and 13 and 2. So use a different color. Make 7x1, 14y1. Make 13x2 and 2y2. And we're going to plug it into the same formula. So slope equals y2 minus y1 over x2 minus x1. Okay, y2 here is, for the red points, what was y2, Nick?
2 and y1 was 14.
2, good, minus, and then y1, which was what, Nick?
14.
14. Over, what's x2, guys? X2, anyone? Seth? 13. And Seth, what's x1? 7. Now watch. We should, if we did it right, also get that our slope is -2. Because it shouldn't matter which 2 points we pick, right? Okay, so our slope, what's 2 minus 14? Brady? -12. And what's 13 minus 7? Gabby? 6. What's -12 divided by 6? Nick? -2. Did we get the same slope? Do we need to do more than 2 points when we're doing these on our own? No, okay? All I want you to do is pick any 2 points and you can find the slope, okay? You do not need to do like what I just did where you pick 2 different examples, right? You can do it to check your work, right? To make sure that you did the slope the right way. But for you guys on your homework or anything, just pick 2 points. Okay, so for B, we're also given a table. We have to use that table to figure out the slope. Aurora, give me any of the points on that table. -1, 2. And Alex, give me another point. Doesn't matter which one.
3 and 2.
3 and 2. So we're going to make our first one x1, y1. And our second one's going to be x2, y2. Do you have these notes? What? Do you have these notes? No, but do you have them? Oh. They're on Canvas. You don't have to write down all the charts or anything. Were you here on Friday?
Yeah.
Do you have your notes from Friday? We're just adding on to these. Yeah. Everyone else is, you guys are writing these on top of the notes from Friday, right? Remember, is y2 minus y1 over x2 minus x1. Who thinks they're pretty good at it by now and can tell me what the slope, plugging in everything, is going to be? With everything plugged in. Gio, go for it.
It's going to be 0 over 3.
Okay, but first plug in everything.
2 minus 2.
Okay,
And 3 minus -1.
good. Do you see how putting parentheses is a little bit helpful here, Gio?
Yeah.
Because we got minus and a minus. Okay, so you said slope, then you got was 0 over 3 plus 1, which is 4. I agree with you. What is 0 divided by 4, Gio?
0.
What do we know about lines that have a slope of 0? Does anyone remember? Gabby? Horizontal, very good. So the table for B is a horizontal line. How could you have told me that it was a horizontal line before even calculating the slope? Before even calculating the slope, what's different about this table? Aya?
All of the y-intercepts are the same.
Very good. All the y coordinates are 2. Do you guys see that? So if your y coordinate is always the same thing, right? But your x coordinate's changing, doesn't that give you a horizontal graph? Okay? Because if your y coordinate is always the same, you're going to get a horizontal line. And C. All right. Carson, give me any of those points for C.
First one and the third one.
First one and the third one? Ah, we did the first and the third. Let's do first and the second for this one. Okay?
I just like how, I don't know.
All right, so first and the second one. Let's make our first coordinate x1, y1. And let's make our second one x2 and y2. Remember, our slope formula is equal to y2 minus y1 all over x2 minus x1. So our slope is equal to 0 minus y1, which is negative 3, over x2, which is negative 3, minus negative 3. Nick, what do you see?
That's gonna be a vertical line.
Ooh, why?
Because all the x's are the same.
Yeah. Okay, so our slope is going to be 0 minus negative 3 is the same as 0 plus 3. You guys with me on that? When we have a minus a negative, that's going to be positive, right? So 0 plus 3, and then negative 3 plus 3 as well. So we've got 3 in the numerator and 0 in the denominator. Anything divided by 0 gives us a slope of undefined, right? Because we can't do 3 divided by 0, right? So our slope is undefined, therefore we know it is a vertical line.
What was 0 divided by 0?
0 divided by 0.
Yeah.
Neighbor. And to the best of your abilities, explain to me why these two are the same. What we're going to write is rise is the change in y, and run is the change in x. What kind of slope is that? Brady? Negative. If it's a horizontal line, what do we know about the slope of this line? Nick? 0. And if the line is vertical, what do we know? Aya? Undefined. Of course. Oh, this easy?
Yeah.
Probably not.
What would a harder version of this look like?
Maybe it would be like multiple choice. It'd be like match the slope with the graph, right? And your multiple choice answers are positive, negative, 0, undefined, and you have these 4 graphs. You could do that?
It's like a lot.
No, now he's gonna make it harder.
No, he won't. Trust me. It's gonna be 4 things, and then you connect the dots.
All right, so this all leads me to the next part of our lesson, okay? We've talked about slope for like a day and a half, right? We're pretty okay with slope by now, right? Now, the form that we use with slope is called slope-intercept form, okay? And it's just that, do you remember when we covered y equals mx plus b? We're still using y equals mx plus b, but now we know our m is our slope and b is now our y-intercept, okay? So if we're looking at a graph, right? This graph, this line is represented by the equation y equals mx plus b. The b is where it crosses the y-axis, okay? And the m is the slope, okay? The slope of the line. Now, there are going to be some examples where we're going to see where y is just equal to a number. We call that a constant function. And all you need to know is that when y equals a number, it's a horizontal line, okay? Because y is going to be a fixed value. So your x values are all changing, but your y is going to stay the same. Okay. Let's check it out. So, we're going to identify the slopes and the y-intercepts of each of these examples, okay? For the first one, we've got y equals 3x minus 4. Remember, it has to follow into the template. Y equals mx plus b. What would my m be for a? Aya? 3. Excellent, okay? It's the number that's attached to x. Why is m not 3x? Nick?
Because that's what the x and m plus b is for.
Yeah, exactly. M needs to be the number next to x, not 3x, okay? So our m is 3, and our y-intercept, or our b, is what? Grace? -4. Okay? Our y-intercept is -4. Our slope is 3. Write a little note to yourself that m is your slope. That's the number next to x. And your b is your y-intercept.
Isn't it y equals mx plus b?
Yep.
Not y equals minus.
Ah, so our b was not +4. It was what?
Oh, negative.
Because we can rewrite this as y equals 3x plus -4. Do you agree with that, JJ?
Yeah, I agree.
So now b becomes -4. Do you see that difference here, guys? Okay. b. Y equals 6.5. Is this in the form y equals mx plus b? No. What's missing? Victor?
The x and the b.
The b is actually there. We're just missing the x. So if we were to write it, y equals mx plus b, right? B is the constant term. B is just the number, right? Do we have a number on the right side? Yeah, 6.5. We're missing the x term. The way we miss the x term is if m is equal to what? What makes that x term go away? M needs to be equal to what? Gabby? 0. Excellent. So this is actually, circle it and write it down here. This is the same as y equals 0x plus 6.5. So now our m, just like Gabby said, is 0, and our b is what? 6.5. All right. C. I see your faces. Don't be intimidated by C. Just look at it. Is it, as the way it is, in slope-intercept form? Mina? No, it's not. So guess what we have to do? Put it into slope-intercept form, okay? Now, what would be required for an equation to be in slope-intercept form? Gabby? Yes. We need to get y by himself. Now, how we do that is we need two different steps. The first step is to add the x term to both sides. So we're going to add 5x to both sides. Okay? We're going to move him over. Once we've added 5x to both sides, we're going to get negative y equals 5x minus 2. Why can't I combine 5x and 2?
Because they're not common.
Mina? They're not like terms. Very good. Okay? They are not like terms. The 5 has an x with it. The 2 does not. Now, all I need to do is divide by -1 to both sides. Because we want to get the y by itself. So now we have y, because -y divided by -1 is just y. And change everything that was positive to a negative, everything that was negative to a positive. So this final expression is -5x plus 2. Now, is this in slope-intercept form, Brooke?
Yeah.
How do you know?
Because it has y equals mx plus b.
Very good. It matches y equals mx plus b. In this equation, what would my m be? What's my slope going to be? JJ?
-5.
Excellent. And Amina, what's my b going to be?
2.
Positive 2. So my slope is -5. My b is positive 2. Form now. Yup, we sure are. So now that we're in slope-intercept form, let's identify our m and let's identify our b. What's my m here? Gabby? Negative dose. And what's my b? Gio? 2. Look, when we're graphing it, okay, we always want to start, put a 1 circled with the y-intercept. Then once you have your y-intercept, use your slope. So start with the y-intercept and then use your slope. If my y-intercept is 2, I'm going to go to the y-axis, go 1, 2, and put a dot. Now, our slope is -2. -2 written as a fraction is what? -2 written as a fraction is what, Grace? -2 over 1. Okay? So now, this is my rise over my run. If my rise is -2, where do I go from here? Nick? Jonathan?
You get 2x -1y.
Nope. Brady?
Go to the 1 on x.
If my rise is -2, what direction do I move? Valerie? Oh, wait.
I'm seeing that.
Just tell me where to move.
Oh, you go down.
Down 2. I probably worded that question wrong. So we go down 2, and then where? Gabby? To the right 1. -2 over +1. Put a dot there. Let's do it one more time. Down 2 to the right 1. And just draw a line that goes through those 3 points. You guys can draw a straight line. I cannot because I'm not a notability.